All right, so what happens if your test statistic falls in between your two critical values? Well, if it falls in between your two critical values, you are, this tells you the probability of your test statistic, which is the same thing as the probability of a type 1 error, right? So if you get a test statistic here, the probability of making a type 1 error can be as high as 95%. So you are not going to reject HO. You are not in a rejection zone here. This is the keep zone. So if your test statistic falls anywhere between your critical values, you are going to fail to reject HO. You are going to get a test statistic which is not significant. In other words, you're going to tell people my test was not significant. My test statistic did not meet the criteria for rejecting HO. If your test statistic fell into this rejection zone or this one, then yay, yeah, it's in a rejection zone. The probability of a type 1 error, if I reject HO, is less than 5%. So I'm going to go ahead, I'm going to say my test is significant, and I'm going to celebrate. Okay, so I don't care how many times you need to write this out, but you see what I have written here? Make sure you memorize that. This is the rule. And if you forget the rule, you're going to make a lot of mistakes. It's just one of those necessary evils you have to remember. If a test statistic is not significant, it means that the probability of the test statistic, which is the same thing as what? The probability of making a type 1 error, all right, was greater than 0.05. What is the probability of making a type 1 error? What else do we call that? We call that alpha. All right, so those are other things you have to remember. Alpha is the probability of making a type 1 error, which is the same thing as the probability of your test statistic. So if the test statistic is not significant, it means that the probability of a type 1 error is greater than 0.05, which means you retain HO, and you're going to say that the results are probably just reflecting sampling error. On the other hand, if the test statistic is significant, it means that the probability of making a type 1 error is less than 5%. Now, you can also use 1% here if you want. If you want to be more conservative, you can use 1%. But anyways, it's less than 5%, so you go ahead and reject HO. You're comfortable with this. And then you can say my results probably reflect something in addition to sampling error. In other words, I probably have a treatment effect. Now, I need to point out something really important. When we do our statistical test, when we get our TS value, it either met the criteria for significant results or it did not. It's either significant or not significant. That is not where you throw in the word probably. When you throw in the word probably is over here with your conclusion. All right, so significant, not significant, that is black and white. It met the criteria, it did not meet the criteria. There's no probably about it, yes or no. But when you conclude, oh, so my results probably are sampling error, that's where you throw in the word probably. I probably have nothing. I probably have sampling error. Down here, I probably have a treatment effect. I probably have something beyond sampling error. Okay, so make sure you don't screw that up. All right, so rejection zones represent the probability of making a type 1 error, right? Because these rejection zones, it's where if you rejected HO, you have a probability of making a mistake, saying something is significant when in fact it is not. All right, so if we are using a table, the best we can do is say, well, look, our test statistic, let's say it's here, our test statistic was greater than the critical value, either in the negative direction or in the positive direction. And if it's in one of those two, then we say, well, it's got to be less than 5% because each tail is 2.5%. So we're going to say our results are significant. But remember, we could always be making a mistake. It happens. But if you're in between, you don't reject HO. If you're in between, there's no way you can make a type 1 error. The only time you can make a type 1 error is if you have rejected HO, which means you're in a rejection zone. That's the only time a type 1 error is possible. All right. And that's because just because we're here, right? Let's say we have a TS here. We're saying that the probability is really, really slim that we belong to HO, right? It's less than 0.05. It's really, really small. But it's nevertheless, there is some possibility, there is some probability that we do in fact belong to HO. In other words, there is a possibility that we are just sampling error. Because that's what HO is, right? HO is null, none, and nothing. It's saying we're just sampling error. So even though you reject it based on your statistics, there's still a possibility that you do belong here, which means you could be making a type 1 error. Okay, so we already talked about that. Oh, what if we were using 0.01 as our alpha? So if we use 0.01, that level of significance is saying, look, I'm only going to reject HO if the probability is less than 1%. Okay, so that's why we say it helps us to establish our criteria, right? Because if we're saying that we're only going to reject HO if the probability of a type 1 error is less than 1%, that means we're looking for the middle 99% of the curve. So once we know the middle 99%, that means we know the outside areas, right, are going to total 1%, which means 0.5% in each tail. We have 0.5%. And then once we know these areas, we can look up our CV, our critical value. All right, so before we can't look up our critical value until we know what area we want in the middle and in each tail. And we don't know what we want in the middle until we set our alpha. So if we set it at 0.01, that means 99% in the middle and 0.5% in each tail. Woo! And go back. And that means once we've got that, the rules are all the same. So in order for us to say something is significant, our test statistic has to be bigger than the critical value because that will put you in a rejection zone. All right. And then we would simply write this instead of p less than 0.05, we now write it p less than 0.01. Same thing, if our test statistic is positive, it's greater than this critical value. That puts us in this rejection zone, which means, again, we're going to reject HO. We're going to say that the risk of a type 1 error is less than 1%. Don't say 0.5%. You got to report the combined areas. So it's less than 1%. We reject HO, and we say P less than 0.01. And if we're in between, then we keep HO, we retain or fail to reject HO. We would say the test statistic is not significant, and we would write it P is greater than 0.01. All right, it's greater than that, so we're going to retain HO. The risk of a type 1 error can be up as high as 99%. We're not going to take that kind of a risk, are we? We don't want type 1 errors floating around in the literature.